Hello and welcome to Super Simple Scala, episode 8. Today I will cover existential types. To do so, I will use this GitHub repository that I created. To follow along, you can check this out by copy-pasting the repository URL, cloning it, and let's see, get Java docs, SBT, auto import, Java version 8, okay, and then give it a second to open. While it's doing that, some basic information that you'll need to know. Scala type system. The very top of the Scala type system is going to be any. Everything is a subclass of any. Then underneath it, there's any val and any ref. Any val is the superclass of all the values, int, float, double. Any ref is a superclass of all user-defined classes, like animal and cat and things of that nature. And then any ref, we're going to create a class animal, which is a superclass of class dog, which is a superclass of nothing. And then we'll create some existentials, and you'll see from there. If I go to the source directory, package main, we'll see 5 different foo methods, foo 1 through 5. They're all the same. They all get the length of an array. And they should really explicitly have the return type. It's good for the compiler, less effort for the compiler to infer return types. The return type is a form of documentation, but return types aren't mandatory. So you can say, you have an array of generic type t, return t's length, because we don't really care about what the type of each element inside the array is. We can create an existential array of t for some type t. We don't know what the type is, but it's for some type t. Third way of writing the exact same thing is we have an array of type t for some type t that is a superclass of nothing and a superclass of nothing and a subclass of any. So superclass of nothing, all right, everything is a superclass of nothing, and a subclass of any. So we're creating an upper bound and a lower bound on the type, and we're saying this type, this generic type, we're taking any generic type as long as it's in this bound. In this case, the bounds are inclusive, so it's everything including any, and then everything including nothing. So pretty much anything can be passed in because the bounds, the Scala type system is everything fits into it. It's not like, oh, there are primitives that don't fit into the type system. Then we have, let's see, array of fill in the blank, print its length. So, this is the same as that, which is the same as the others. And then we can say array of type fill in the blank, where the blank that we're filling in is nothing and up, and it's also any and down. So it's in this little rangey, right? But the range doesn't have to be nothing and up. It could be dog and up, it could be animal and up, it could be any ref and up. We can define the range of the type anywhere we want. And each type, each generic can have its own range in which it can be accepted and also be valid. So we create an animal that extends any ref. You don't have to explicitly extend any ref. Even if you were to leave out the extends any ref and run this code, what would end up happening is that if we were to pull it up, oops, So if we have the xprint parser, so we're going to be outputting the parser phase of the compilation. So if we go to the terminal, sbt, and then give it a second, and then compile, we should, from compilation, we should see the output of the parser compilation phase. It's messy, but this is sort of desugared code. In the output of the parser compilation phase, if we look at abstract class animal, we'll see that animal extends scala.anyref. And then here there's the initializer and print animal, whatever. But the point is that this is the same as this. It's just that you don't have to be so explicit, right? So we have animal, and it's in this little location in the class hierarchy. And then we have dog, which is just underneath it. Animal has a print animal method, dog has a print dog method. In Scala, curly braces are used when you need multiple lines. You can leave out the curly braces if it's one line. The same philosophy of curly braces for multiple lines also applies if you have like parameters that across multiple lines. You would use curly braces there. But don't worry too much about that. So let's say that we have a bunch of different dogs, and the concrete type of all these dogs is the same. It's all dog. But the reference type is different. The reference types are going to be dog, animal, anyref, and any, where the reference type can be the same type as the concrete type, or it can be a super type. I'm sure you've seen this in Java or other languages where you have references or pointers. If you were to try to do a value dog5 of type nothing equals new dog, you would get expression doesn't conform to expected type, because nothing is below dog on the type hierarchy, and you can't put something that's below something that's underneath in place of something that's above. You can't go in that direction. You can go in this direction, if that makes any sense. So that's illegal. Anyway, we have these 4 dogs, and they have different reference types. Now, let's put them into little lists where the list is generic and the generic types have bounds on their generic parameter, right? So instead of it just being list of type T, it's list of type T with an upper bound and a lower bound. Keeping in mind that sort of the underscore way of writing it is the same as for some type that has this lower bound and this upper bound. So let's create a list of D1 so that the concrete type of this is going to be list of dog. And we're going to assign that to a reference that is of type list that is somewhere in between nothing and any inclusive, right? So we're becoming the reference type is less specific than the actual type. The reference type says, it's a list of something in this range, whereas the concrete type says, no, it's a list of dog, right? So concrete type, reference type. These two are identical. It's just to sort of give you an idea of the 2 different ways of writing it. In future versions, this is going to become like deprecated, but it sort of gives you sort of the mentality of what's going on. Okay. So we're going to create another. So this is a range. I'm calling it a range because the list contains a type that's within this range. Any, nothing on the bottom, any on the top. Let's create another range. This range has animal on the bottom and any on the top. It's range 1. Range 2 has dog on the bottom, animal on the top. Range 3 has nothing on the bottom and then dog on the top. Range 4 has dog on the bottom and dog on the top. As you can guess, this is exactly the same as just writing. I mean, this is, for most cases, equivalent to just writing a list of dog, because the top of the range and the bottom of the range are the same. So if it can't be anything, if it can't be a superclass of dog and it can't be a subclass of dog, it has to be, process of elimination. The type of the thing has to be dog, right? So let's try using these type ranges and see how they behave. Okay, so get function 0, range.apply. If you've ever done like, so this is a list. If you've ever done something like val 0th element equals that at 0, writing parentheses 0 is the same as writing dot apply 0. This dot apply is sort of like the glue between functions and objects. It allows you to treat objects as functions. So in this case, the apply method will, we're going to do a decomposition on the apply method. We're going to convert that apply method into a value, right? So if we were to do, val 0 element equals range 0 at 0. Okay, so if we look at range 0 is a list of some type that is in this range. If we get the 0th element of something that's some type in this range, we don't know where in this range it could be, but we have to be type safe. So we have to pick the safest type in the range. What is the safest type in this range to assign a reference to? It's going to be the most general type. It's going to be the type that is the least specific. So if we were to have this range and we were to say, all right, give me an element in this range, and we don't know what the type is, but we had to be safe and guess the least specific type, what type would we end up with? Oh, we would end up with type any, because that's the least specific type. So the 0th element is going to be of type any. So this range apply method, if we were to turn it into a value, would become a value that represents a function that takes in an int, in this case an index, and returns something of type any, because that's just how it decomposes. If we look, so we're returning the upper bound of the range of types. In this case, is any. If we look at the upper bound on range 1, it's also any. So if we do range 1.apply, the return type is going to be any. If we look at range 2, we've got a list of something that at the most specific would be a dog, and at the most general is an animal. If we get something out of the list and we don't know what we're getting, the safe thing to do would be to give it a reference type of animal. Here, dog is at the top of the range, so we're returning dog. Same thing, dog is at the top of the range, we're returning dog. These ranges, they're type safe. You're never going to it's not like, void pointers where like, oh, I didn't realize I mean, under the hood, it's kind of like that, but you're never going to like be allowed to call a method that is illegal, right? The compiler won't let you. Right, so in the case of calling the apply method, we're getting the generic and assigning it to a value, so we had to be as general as possible. In the case of this concat method, : remember that if you had something like list 1, 2, 3, : 4, that produces a new list with that concatenated. What's going on here? So if we were to do something like list val L1 equals list 1, 2, 3, val L2 equals L1 concatenate for. Why is this concatenation thing not working? Whatever, close enough. Right, so that works. Oh, sorry, the concatenate goes on the other side. For colon L1. Yeah, so if there's a colon there, if it, I get confused with this sometimes, but the so remember our first episode where this is equivalent to dot colon 4, where that requires parentheses. So anyway, this colon is appending to the front of the list, and we're saying this list append method, this colon method, we're saying, what's the type of that method if we were to turn it into a value? So think about what colon does for a second. Okay, let's say we have we don't know what the type of, let's say we have a list that, could be, it could be a list of cats, or it could be a list of animals, but we don't know which one it is, right? If it's a list of cats and we put in an animal, we could end up putting in a dog into the list of cats, and then the list would be broken, right? So because we don't know what the type is, we have to pick the safest type in the range so that everything compiles. So what's the safest type in the range, right? The safest type for the add method would be, if it's a list that, the most general could hold any animal and the most specific could hold a cat, to be safe, we have to be as specific as possible when putting into the list. So we're going to go specific. We're going to go cat, right? Before, with the apply method, we were going general, but now we're going specific instead to be type safe. So if we look here, so now we're looking at our most specific type. This can contain at its most specific nothing and its most general anything. But we're adding to the list and we want to be safe, so we're going to go to the more specific. So we're going to end up with nothing, right? And that's why we have nothing here. So we put in nothing, and then we're going to get out a list of whatever type. But whatever we get out has to be general for it to be type safe. So going in, specific, going out, general, keeps it type safe. Right? So at the most specific animal, the most general any. Most specific dog, most general animal. Most specific nothing, most general dog. Most specific dog, most general dog. In this case, our lower bound and our upper bound are the same. Let's say that we wanted to call a method like the print animal method on the first element of our list. If we look at our list, the first list could be anything from here to there, from nothing to anything. If we try to call, dot print animal, that only works if it's an animal, but it might not be an animal. It could be, something that's more general than an animal that doesn't have that method, so we can't allow it. It's not type safe. So if we were to say oopsies, went too far. Val 0 equals range apply, or just get rid of that. Range 0 at 0 dot print animal it's not allowed. You cannot resolve simple print animal because we don't know for certain that that thing, the element in the list, has the print animal method. We can't guarantee it's type safe, so it won't compile, right? Let's look at the next one. It could be anything from animal to any. Well, it could be an animal, and then it'll have that method, or it could be a superclass of animal, in which case it won't. And we don't know, based on the reference type, which one it is. So to be safe, we have to say, sorry, we cannot guarantee that this object has this method. So if you try to run this method, you're going to get a compile error, right? So debug. Let's see that compile error. Value print animal is not a member of, bam. What about our other three? Right, this isn't rocket science, right? So our other three, it could be from nothing to dog. So it's either a dog, or oh, sorry, I skipped one. It's either dog. It's the most specific, it's a dog, and the most general, it's an animal, inclusive. So no matter what it is, it should have the print animal method, because no matter anything in the range is an animal, anything in the range has that method, even if it's dog, because inheritance. So calling that method on an element of this list will compile, right? It's guaranteed, that method is guaranteed to be there. Same thing with here, either dog or a subclass of dog. Well, dog gets that method from animal, and anything that is a subclass of dog gets that method also. So it'll compile. And obviously, if the range is, bottom of the range is dog and top of the range is dog, and we know it's a dog, then dog will get the method from animal. So we see how these three you can call the print animal method, and these two you can't call the print animal method. Same thing if you were to try to assign something to a reference that is of type dog, you would have to look at, what's the upper bound, what's the lower bound, can I guarantee that this thing is at least a dog. Right, so here we require that whatever is being passed in is a dog. Range 2 is, it's a dog or superclass of dog. If it's a superclass of dog, it's not a dog. We can't pass it into that method. It's not type safe. It won't compile. So we're seeing this very clear pattern. That's everything that you need to know about existential types. So if you ever see, underscore, so you understand the notion of type bounds, so, most specific type, most general type, and you should understand the notion of, there exists a type within these bounds, but we don't know what the type is, but we want to be type safe. Cool.